Hey, from West Virginia. How's everybody doing? I hope you're doing great. Here we are, ready for joke of the day because it is the best part of the day. So, my brother, he didn't like his beard, but then it grew on him. All right, so let's grow our mathematical abilities and take a look at combining up like terms. Now, we need some definitions before we can get into this idea of being able to combine up like terms. First, let's take a look at what a term itself is. A term is a number, a variable, or a product or a quotient. In other words, a combination of numbers and variables. That's what a term is. Now, terms within them, within a term, you can have multiplication or division. What you cannot have within a term is addition or subtraction. The addition and the subtraction are what separate your terms. They are always separated by addition and subtraction. This is how you can recognize where your terms are. Now, once you've identified that you have a term, there are parts to the terms. There is the variable, but oftentimes there's this number that sits in front of the variable. That number that sits in front of the variable is what's called the coefficient of the term. The coefficient is that number that sits in front. Now, once you've identified that you have a whole bunch of terms, some of them will be alike and some of them won't be alike. And so this is where we get into this idea of like terms. Being that mathematicians are not creative and we call it like we see it, like terms are going to be alike. So what is it that's making them alike? It's the variables. So like terms are going to have the same variables, but more than that, those variables are going to be to the same power. So in other words, if I have something that looks like this, say for instance a 3x squared y and perhaps a 5xy squared. Now notice by this definition, I don't really care what's happening with the coefficient. Remember, the coefficient is the number that's in front of the variables. So here's my coefficient of 3. Here's my coefficient of 5, and by this definition of like terms, I don't really care what's happening to the coefficient. I'm not even going to pay any attention to it. I'm looking at the variables. But it says they have the same variables. Well, this has an x and a y. This also has an x and a y. So it feels like they might be like terms. But this says those variables are to the same power. Well, see, this is x squared. This is x to the first power. They are not to the same power. Now this is a y to the first, that's a y to the second. They are not to the same power. So these are not like terms. Like terms have the same variables and those variables are to the same power. So if, for instance, that 3x squared y and then that was a 5x squared y, those would be like terms. Even though the coefficients are different, the variables are the same and they are to the same power. X squared, y, y. Or for that matter, if we said, let's call it xy squared and xy squared, that would be the same as well. And that's perfectly fine. They would be like terms. Those variables are to the same power. So now that we know what like terms look alike, let's look at this idea of being able to combine up those like terms. So in order to combine up like terms, we need to get this idea that in this example, it says I have 7 of those letter x. Now the word of in math always means multiplication. Of means multiplication. So in other words, when this is sitting beside each other, I've said before, when things sit up against each other, that indicates multiplication. So 7 times x would indicate 7 of those x's. So it's like I've got this pile in front of me of 7 of the letter x. 7 of those x's sitting in front of me. Well, now I'm going to add to my pile 3 of those x's are sitting beside each other, indicating multiplication. Multiplication means of. So 7 of these x's, I'm going to throw 3 more of these x's into the pile. Well, how many of those x's do I have into the pile? I have 10 of those x's in that pile. 10 of those x's. So in other words, what I'm going to do is I'm going to take those coefficients, that 7 and that 3, I'm going to add those coefficients together. I'm going to keep what's making them alike. It's the variable that's making them alike. And this, my friends, is how you combine up your like terms. What you do is you add or subtract those coefficients. Add or subtract the coefficients. and keep the variables, because that is what's making them alike. So let's take a look at our second example. We have a 21C plus an 18C plus a 31B minus a 3B. Well, I'm going to combine up the like terms, remembering that like terms have the same variables, those variables to the same power. So how do I identify those like terms? Well, this says I have 21 of these C's sitting in my pile. I'm going to throw 18 more of these C's into the pile. So 21 C's, 18 more of those C's. How many C's do I have now? Well, 21 and 18 is going to give me 39. I have 39 of these C's sitting in my pile. But as well in the pile, I have 31 of these letter B's in that pile. But this says I take out 3 of those B's. So where I said to get that 39C, I'm going to take my 21 and my 18, I'm going to add them together and keep the C. This says what I'm going to do is I'm going to take that 31 and I'm going to subtract the 3 and keep that variable that's making them alike, which is the B. Similar idea of saying I have 31 of those B's, I'm taking out 3. How many of those B's are left? Well, 31 minus 3 will give me 28. So I have 28 of those B's left. Now remember, the idea of like terms, I can only put together things that are alike. These are C's, these are B's. I can't put them together because they're C's and they're B's. There's nothing I can do. So this is the best that it gets, 39C plus 28B. All right, let's take a look at our last one. I have 3 of these letter J's sitting in front of me, 4 of these letter K's, 5 of these letter L's. I'm going to throw 6 more K's into the pile. I'm going to take out 2 of these L's. Well, let's find those like terms. 3 of these J's will combine up with, oh, there's no other J's. So they can't combine with anything. So I'm just going to carry it down as it is. 3 of those J's. Now let's find the rest of those like terms. Well, here's 4 of these K's, and I said I'm going to put 6 more of those K's into the pile. 4 K's, throw 6 more in. How many K's are now into the pile? Well, that gives me 10 of those K's into the pile. Again, it's because I'm going to take that 4 and that 6, I'm going to add them together to get 10 and keep the variable that's making them alike. Now what I'm going to do is I'm going to continue on finding the rest of the like terms. Well, I've got 5 of these L's in that pile. I'm going to take out 2 of those L's. If I have 5 of the L's and I take out 2 of them, how many of them are left? I have 3 of those L's left. And again, the idea is I'm going to take that 5, take out the 2, and retain what's making the like, which is the L. 5 minus 2 is 3. Now, are any of these alike that I can put together? 3 of the J's, 10 of the K's, 3 of the L's. That's K's, J's, and L's. I cannot put them together. They are not alike. So this is as good as that one gets. So this is how you combine up like terms. You add or subtract the coefficients. You keep those variables the way they are because that's what's making them alike. We like that they're like terms. Don't mess that up. Keep those variables. So I hope that helps. Have a great day.